My name is Sean Ely. I'm head of product at TDengine. Today we're going to be talking about TDengine and a new release, the TDengine PI Connector. TDengine is a modern database purpose-built for time series data. It was built from the ground up to handle the unique requirements around time series data. Its natively distributed design can easily support massive scales, high availability, and distributed systems. It is incredibly quick to get started with TDengine. Its core is open source, which can be freely downloaded or pulled from Docker Hub, and uses a very simple interface for querying data based on SQL, allowing new users to get started in minutes. TDengine can be hosted on-prem, or you can try our fully managed cloud service, which is free to start. TDengine currently has over 160,000 running instances all across the world. While our time series solution is applicable for many use cases, we're currently focused on the industrial sector with a strategy of understanding the needs and pain points of industrial companies. We took a look at one of the leading historians for the industry, the PI system from OSIsoft and Aviva. And from our assessment, we felt that TDengine can provide enhanced capabilities for PI users. So we set out to build a powerful hybrid solution with PI, where the integration works out of the box, is easy to set up, and requires no prior knowledge of TDengine. So let's take a look at the architectural diagram of what we built. There's two main components that we released. We have the TDengine PI Connector, which is a Windows service. It reads data from the PI Data Archive and PI AF, and it writes that data to TDengine Cloud. We also built a TDengine data reference, which when used with AF, allows customers to view data within TDengine Cloud natively within PI AF, to use it within the PI Data Link, as well as PI Vision. It provides a powerful two-way access for sending data to TDengine and then viewing it back within PI. Some of the other capabilities of the connector service is that it has streaming data to the cloud. It can backfill on startups. So it's got a utility for backfilling data, and it's got automatic backfill so that if there's ever an interruption in the service, it will look at the latest point sent to the cloud, and it will automatically backfill the missing data. So our goal with building this connector was to provide the best of both worlds. We want customers to retain their investment in PI and still use all the capabilities that PI is great at. We also wanted to provide a modern database with data analytics, powerful open source tools, and additional capabilities for working with your data. So diving into the data connector and how it works, there are two modes for replicating data. You can send data using PI points. So if you're not using AF, you can just go to the PI Data Archive, assemble a list of PI points you want replicated. We've got a handy tool for building that point list where you can search based on tag mass, descriptions, and you can build your list of points you want replicated. Once you build that list, the connector will automatically create all the necessary tables, structure within TDengine Cloud, and will start streaming data. We also have a PI AF mode. So for PI customers who are using AF, we built a mode for replicating data based off AF element templates. To use this, you select the AF element template name. So in this scenario, we have a template called meter template. And then every AF element based on that template will be created, we'll have a table created within TDengine, and all that data will be automatically streamed. The benefit of using the AF element template mode is that all the data within the AF element, so all your attribute data, will be added as one table within TDengine. This makes it easier to work with and easier to query and has a nicer structure for data analytics. So from there, I want to give a demo of what we built. Let me get my screen set up. So here I've got a normal Pi system. Here I've got Pi System Explorer open. Here you'll see we've got an AF element tree. We have California and 3 cities within it. Let's look at San Francisco. So within San Francisco, we have a number of meters. Each meter is based on a meter template. So we've got an AF element template. So I'll be showing you the template mode. Within that template, we've defined 3 attributes: current, power, and voltage. Current is a pi tag, and voltage is a pi tag. Power is a formula, current times voltage. So we also created a simulator. That simulator is writing 10,000 pi points to the Pi data archive. And it's writing the current and voltage points. Okay, so everything here is just typical Pi setup. So to replicate data to TDengine, we selected this template, the meter template, and all of the table structures were done automatically. Let me navigate to TDengine Cloud and show you what that looks like within TDengine. So from our website, tdengine.com, I'm going to navigate to Cloud. From here, if you're new, you can create an account. No credit card required to start, just need your name and email. I already have an account, so I'm going to log in. And here I have an instance called Pi Demo. We have a table structure with, if you're familiar with relational databases, should be familiar. So here I have a Pi database, and within it, I have these super tables. Each super table has a number of tables associated with it. So there's actually a pretty good mapping between the Pi AF structure and TDengine, and that each super table is essentially a template. So here we have meter template. We created a super table called meter template as well. When we go to meter template, we look at what's in there. We have a timestamp, current, power, and voltage. And we're also pulling in the status and the units of measures for each point. We're also pulling in the element ID for each of the elements. So if I go and look at a table, here you have the same columns, and here's some of the data for it. You've got timestamp, current, power, and voltage. So all of this structure was automatically created once we gave it the template name. If I look at some quick charting, just so you can see what it looks like. So I have timestamp on one axis, when I do current, power, voltage on the other. Here's what it looks like for this meter 10,000. We got current, power, voltage, looks like a sinusoid wave. And so now I want to show, this is what it looks like with the Pi data connector writing data to TDengine. I also want to show what it looks like with the data reference getting data back within Pi. So now that we've written data, and this is updating in real time, if you go back to Pi System Explorer, we'll look at a new kind of element tree called TD meters. In TD meters, I added 3 elements. Each of these elements is based off a TD meter template. If I go and look at the attributes for TD meter 10,001, I've got the same three attributes: current, power, and voltage. But here, instead of using pi points, I'm using TDengine points. So here, the data reference is TDengine, and it's connected to the cloud server. It's looking at the column called current, and it's looking at the meter 10,001 table. Same for power and voltage. We're looking at different columns within the same table. So each of these acts just like a pi point, so I can trend it and look at the current over time. And this is all data from TDengine. There's no pi point created when we're pulling data back in from TDengine. We can also pull in data that's not within pi. There's no requirement that the data go from pi to TDengine. It just makes it easy to replicate data with the TDengine PI Connector, and then you can view any data within TDengine with the data reference back within pi. So if I look at here, let's edit this, create a new one. So we're now in Pi Vision. I'm looking at my AF structure. I've got TD meters. And if I pull in the same one, I've got the attributes current, power, voltage, adding it to the trend. Here you can see the most recent data, the last 8 hours for these points. And it can be, let's configure it. I kind of like different axes. And so it acts just like a pi point. So, and you can have pi data alongside TDengine data within Pi Vision. If you're not a Pi Vision user, you can also use many of the open source integrations we have, like Grafana. Here we have the same meter, 10,001, current, power, voltage. Here it's being mapped in Grafana in real time. You can update it and see the data is being updated. So within TDengine, we have many popular programming connectors, such as Java, Python, C#, where you can easily get data out of TDengine, work with it, do your data analytics, and you can either write it back or consume it however you want. We also have many open source integrations, such as Grafana and Google Data Studio, and we're planning to add more as well. In summary, thank you for taking the time to watch my demo today. I went over the TDengine PI Connector and the TDengine data reference. I showed you how it replicates data to the cloud, and it was really easy with just a few clicks. I showed you how it's a powerful hybrid solution where you can write data to TDengine, you can view data back within Pi, you can use the capabilities that you like with Pi, and you can use the capabilities like in TDengine. You're not stuck with anything. You can use the best for your current situation. TDengine is a very open system. The core code is open source. We make it very easy to get your data out and connect to many open source tools. And with TDengine, the connector is free to use as long as you're using TDengine Cloud, and there's no time-consuming or expensive licenses. So please go to tdengine.com, check out our website. You can reach out to business@tdengine.com to get started today with the TDengine PI Connector. Thank you.